Hi everyone, in this video we are going to solve a problem. The problem name is number of good paths and the problem number is 2421. So let's quickly see what this problem say. There is a tree that is connected undirected graph with no cycle. So in this example you can see that we have a tree that has no loop or we can say cycle, right? And consisting of n nodes numbered from 0 to n minus 1. In this example n is nothing but 5. So you can see that all the nodes are between 0 to n minus 1, that is 4. Starting from 0 and the maximum value is 4, right? And exactly n minus 1 edges. Okay. You are given a zero index integer array vals of length n. Here you guys can see that in input we have a value, right? Vals array. This value array is nothing but denotes the value of ith node. So here in example you can see that on zero indexes we have nothing but 1. So we can say that on zero node we have nothing but value 1, right? So it denotes the value of that particular node, what value that particular node contain, right? After that, you are also given a 2D integer array edge. This is nothing but 2D integer array, right? So it says that edges of I is equal to A of I, B of I. That means if here we can say 0 to 1, that means we have an edge which are going from 0 node to 1 node. Here 0 to 2, that means we have an edge which is 0 to 2 node. And as it is an undirected graph, so we can say the edge also going from 1 to 0 and 2 to 0 as well, right? So this is nothing but this telling us the path between the nodes, right? Now guys, we are also given one more thing, that is good path. A good path is a simple path that satisfies the following condition. The first condition is the starting node and the ending node have same value. Now guys, there is a good path in this tree. Let me remove all these things first of all. Now the good path says that guys, a node, let's say there are so many nodes. Okay, fine. Now guys, we can say this is a good path only and only if the value of that starting node is nothing but let's say 5 and the ending node also value should be 5, right? So far we know all this, right? Now guys, there is one more line, that is all node between the starting node and the ending node have a value less than or equal to the starting node. See guys, if we are having a 3 node in this example, so we can say that all the values on these 3 nodes should be less than or equal to this 5 value, right? Then only this path will consider as a good path, otherwise this will not be a good path. Okay, return the number of distinct good path. Now guys, we have to return a distinct good path from this particular tree or whatever tree will be given in our input, right? Okay. Note that a path and its reverse are counted as same path. For example, 0 to 1 is considered to be the same, 1 to 0. A single node is also considered a valid path. Now guys, you can see that if this path exists, right, then the reverse of this path is also same path. We can't consider it as a different one. So that's what it want to say, right? Now guys, a single node, let's say there is 6. So we can say this is also good path. Even though this is not a valid path, right? We can't move 5 to 5 because we have a value greater than 5. But this single node is also a good path. I hope this much is clear. Now let's quickly understand this example, see how many good paths we have in this example. Now guys, you can see that here we have a 5 node, right? And also the edges given, value also given. Now let's quickly see how many good paths we have in this example. We can consider all the nodes are good path because single node also be a good path. So 5 is sure, right? 5 good paths we have in this tree. Now let's find more good path. So what I can do, see the path, this can be a good path. We don't know this is a good path or not, but this can be a good path because this is starting, this is ending, right? So, and this also can be a good path. Let me take a different color. Fine. So now guys, did you notice that here value is 1, this value is 3. Both value are not same, right? So this can't be a good path. So let me remove this. Now here we can see the value is same, right? But now let's find out the all the value between these nodes are less than or equal to 3 or not. So we have 1, we have 2. Like we can say that all the value between this path are less than or equal to 3. So we can say this is nothing but a good path. So let me define. This is one path we have. So we have total 5 plus 1, that is 6 path. And in the output also you can see that we are getting a 6 path. So this is the solution of this example. I hope you understood the problem now. Now let's quickly see the logic part, how we can solve this particular problem. So guys, let me write here logic first. Okay. So guys, can you tell me which algorithm we can use in this particular problem? You guys can see that for every node we need to find a starting and ending node, right? So that we can say that whether the starting and ending value is greater than or less than my particular node. So for that we can use a union find, which help us to tell us the parent of every particular node. So we are going to use a union find. So let me write a union find. So guys, in union find we need to maintain either dictionary or hash map, right? So let me maintain dictionary. For 0 we have root node 0 by default, 1 4 same, and 2 3 and 4, right? So let me mention here 2 3 and 4. Fine. Now guys, we also need to maintain the maximum value, right? So we can say for first node 0 node we have a maximum value nothing but 1 right now. And how many time 1 game? 1. For 2 node also we can say the maximum value is 2. Alright. And how many time it come? Let me write here 1. Fine. For 3 node the maximum value is 1 right now. Fine. And how many time? 1 time. 4 also we have say maximum time is 3. And let me write a 1. Fine. And here we can say the maximum value is nothing but 3. And how many time? 1 time. Fine. So this is a maximum value which will tell at that particular node what is the maximum value we can get, right? Now guys, what we are going to do, we are going to start from 0 node. No, we are going to start from that particular node which have a smaller value. So guys, we can see that here we have a value which are telling us that what are the values stand at that particular node. So you guys can see that the smallest value we are getting 1, 1, then after 2, then 3, then 3, right? So let me maintain a range. Here we have 1, here we 3, 2, and 1, and 3, right? Now guys, the smallest value is nothing but 1, right? So let me maintain also index 0, this is 1, this is 2, this is 3, this is 4. So smallest value is 1, so we can write first index is 0. After that, smallest value is nothing but again this one, and the index is nothing but 3. So let me write 3. Then after 1 we have a 2, the index is same 2. After that we have smallest value nothing but 3, so index is nothing but 1. After that, smallest value is nothing but 3, that is the index is 4. So we are going to follow this particular path. Let me tell you here, this particular path we are going to follow now. We are going to start from 0 node, then 3 node, then 2 node, then 1 node, then 4 node. I hope this much is clear to you. We are going to start from that particular node which have a smallest value. Now guys, let's quickly start from the 0 node. So let me write a 0 current node, and after that how many paths can be possible from that particular node, that will be tell by our adjacent list. We will maintain that particular as well. So first of all, find out the root of 0 node, that is nothing but 0 by default, right? Okay, and the next first path we are going to take, that is 1. We can go from 0 to 1 and 2, right? So we're going to take 1, and the root of 1 is also 1, because we know by default they have a value 1. After that, first of all, we need to check the condition whether the particular adjacent or child node has a greater value or less value. If it has a greater value, then we can't take that particular path, but if it has a less value, then we will take it, right? So here we can say our current node has 1, but child node has 3. We can't take it. Okay, now let's take another path. That is, we can go from 0 to 2 as well. This has a value nothing but 2, right? So we can't take that one as well, because 0 has only one value. Remove that particular path as well, right? Now we are not left with any more path. Now we are going to start from another node, that is 3, right? So guys, first of all, find the root of 3. That is nothing but 3 only, right? The first path we are going to take 3 to 2. There is only one path exists, that is 2, right? So the root of 2 is nothing but 2 only. Okay. So does the value of 3 is greater than 2? No, you can see 3 value is 1 and the value of 2 is nothing but 2, right? So we also can't take this particular path. Fine. Now let's take the another node, that is 2. Okay, the root of 2 is nothing but 2 only. So let me write 2. And the path exists from 2 node are 3, right? So we can take first of all 0. After that we will take 3 and then 4, right? So for 0, we can say the value is greater now. The value of current node is greater than the child node. So first of all, find the 0. The root node is 0. Okay. And the value is nothing but greater than 2 node value is greater than the 0 node value. But now guys, notice that the value of this one is 1 and the value of this one is 2, right? Max value. So we can't add that particular path in our answer, but we can follow this particular path, right? Until and unless we will not add that particular path when we know that the value are not same. But we will take that particular path. So we can say now the max value is nothing but 2. Fine. And the parent of 0 node is nothing but 2 node. So we can change this parent. We can say now 0 node has a parent nothing but 2. Now guys, there is another path exists, that is 2 to 3, right? So we are going to take 3. The root node of 3 is nothing but 3. Okay. The 3 value is also smaller than our current node. So we can take that particular path. But the value are not same max value. So if value are not same, but we will follow that particular path. So we will say 3 node has a max value nothing but now 2. And the parent of 3 is nothing but, we can say now 2. Fine. Now there is also one path exit from 2 to 4. From 2 to 4 we have one path, and 4 root is nothing but 4. Alright. The value of 4 now it's greater. Now our child node value is greater, so we can't take that particular path. So remove this particular path, and we are not left with any more path with 2. So move to the next node. This is 1. Now for 1, the root node is 1. Fine. Now guys, from 1 we have only one path, that is 0. And 0 root is not 0. 0 root is 2. You can see in dictionary 0 root is 2. So we are going to take 2 node. Okay, 2 node, and the 2 node value is greater than or smaller than. You can see from one node has a value 3 and 0 node has a value 2. So we can say our current node is greater than our child node. So we will take that particular path. And the max value are not same, but still we can take that particular path. We will not add in our answer, but we will take that particular path. So 3 is going to be replaced here. The max value now 2 has 3. Now guys, before moving to the next node, we have to add that particular parent as well, right? So we can say now 2 parent is nothing but 1, because we have take that max value. Now let's move to the next node. Fine. We have a 4 node, and the root of 4 is nothing but 4, and the path exists from that particular node is nothing but only one, that is 2, right? We can move from 4 to 2, right? And the 2 has a root node that is nothing but 1. Root of 2 is not 2 now, it's 1, right? Okay, so we are going to take 1, and you guys can see that the value of 1, that is 3, right? You can see 3 is not smaller than, it is equal then. So we are going to take that particular path as well, because we know that if the value is smaller than, then we can't take it. But if it is the same, then we can take it. Alright, and also did you notice one thing? The max value are same, 3, and here also 3. So now guys, if it is the same, then we can add in our answer. So we can say that now guys, answer is going to be added. Answer is going to be added. The max count. Here is the max count 1. Here is also 1. So we can multiply it. We can say 1 into 1 nothing but 1. So we have a one path right now. So they are giving just one path, that is nothing but this one. I hope this much is clear. Okay, so now answer is nothing but 1 right now. Okay. After that guys, we can move to the next path. And here we don't have any more path with 4. So we can move to the next node. And also next node doesn't exist. So we can say exit from our loop, and answer is nothing but 1. Now here answer is 1 and here answer is 6. Why? They told us that every single node also a good path. So we have 5 nodes. You can see. So we are going to add all the nodes. So answer plus equal to n. That is nothing but 1 plus 5, that is nothing but 6. So we are going to return our 6 answer. I hope this much is clear to you. If you still did not understand, let's move to the code part and see how we can implement this particular algorithm, how we can get our answer. So guys, first of all, we have to maintain an adjacent list. So I'm going to say adjacent list is going to be right now empty for every node. Okay. So I'm going to say for underscore I in range of n. And what is n? We have to tell the n also. N is nothing but length of value. So we can say n is nothing but length of our values. Let me that values. Fine. Now we have created an adjacent list, means we don't have any path for that particular node. So let's fill it. So I'm going to say for a comma b in adjacent. I can say adjacent list of that particular a. We can go to b. So append b. As this is undirected graph, so we can say adjacent list of b also we can go to a, right? Means we have a path from a to b and b to a. All right. So now guys, we have to maintain a max value and max count. So I can say max value and count, right? Which will be a 2D array. So the first value is nothing but value, and the second value is nothing but 1. By default, we have a same value for every particular node, and count is remains 1 only, right? After that, we can say for value is not vals. I guess now this is much clear. We have maintained a maximum value, maximum count for every node. By default, same value and count only 1. All right, once we have done this, we have to maintain one more thing. That is nothing but guys, we have to maintain a dictionary for union find, right? So we can say dictionary by default is going to have a same root. So I is going to have a same root I for I in range of n. I have this much is clear. One thing is left now, guys. That is we are going to start from that particular node which is smallest, and that will be tell by our sorting, right? We can do sort, and then only we can start from that particular node. So I'm going to say nodes is going to be equal to, by default I'm going to say first of all list range of n. I created a list which are from 0 to n minus 1. Now I'm going to sort this particular list on the basis of that particular value. So I can say nodes dot sort, and key is nothing but guys lambda x and value of x. So see guys, I have a list created 0, 1, 2 and 3, right? Let's say our n is nothing but 4. So let's take it 5 only. So here I'm going to sort on not on the basis of 0. I'm going to sort on the basis of 0 index value of that particular vals. So on values we have 0 index value nothing but, in first example we can see, you guys can see that we have nothing but 1, right? So it is going to take that particular value and it is going to sort our this nodes list on the basis of value list. I hope this much is clear to you. Now we are going to traverse this particular node, right? So we can say for node in nodes. All right, we are going to say find the root of this particular node first of all. So I'm going to say a current parent. Okay, and this parent is nothing going to be tell us by the find function, and in find function I'm going to pass this particular node. So let me define one find function as well. So I'm going to say define find, and that particular find we are going to take that particular node. Okay, and we will return the root of that particular node. So if the node is equal to dictionary of our node, then we can say this is the root. So return that particular dictionary of node. But if it's not the case, that means the root is different from that particular key. We can go to that particular key where the root exists. So we can say dictionary of that particular node is going to be equal to find of that particular dictionary of node. And once we are done, we can return our dictionary of node. So this is going to tell us the root of every particular node. Okay. Once we got a root of that particular node, we can say traverse all the path which exist from that particular node. So for I can say new node in adjacent list of that particular node. Okay. I'm going to take the root of every path as well, right? So I can say a child parent is going to equal to find a new node. So here this is going to tell us the root of child parent as well. Fine. Now once we got all this, we are going to check one condition, that is nothing but guys, if the value of our child parent is smaller than current parent, then only we can move that particular path, otherwise we can't, right? So now guys, what we can do, we can say that if values of child parent is smaller than, only we can move. So we can say if it is greater than values of our current parent, then we can't take that particular path. And also one more condition guys, if child parent and the current parent are same, then we can't take that particular path because we are standing on the one particular root, right? We can say if child parent is equal to current parent, then we can't take that particular parent, right? So we can say continue. Fine. But if it is not the case, means the value of child parent is less than our current parent, then we can take that particular path. We can take either that particular path or we can follow that particular path. If the max value are same, then we can take that particular path, right? So we can say check one more condition. If max value count of that particular child parent and 0 indexes tell us the max value, 1 indexes tell us the max count. So if the 0 indexes means max value same as max value of current parent, of 0 indexes means the same as the max value of parent, then you can take that particular path as you can add in our answer as well. So we are going to say if that are same, then what we are going to do, we are going to add in our answer, right? So we can say, let me make it little above. So now guys, we can say our answer, and I haven't defined answer, so let me define here answer before find node. Answer is going to be nothing but answer is going to be by default n, because question says that every single node is also a good path, right? So by default n node should be there definitely, right? So answer has n right now, means we have n good path. Now it will add into our answer as well. Answer plus equal to max value count of child parent of 1, means we are going to multiply with the max count for both node child parent and current parent. So multiply by max value count of current parent and the index is 1. Fine. Once we are done with this, we are going to see that also. Now count is increases because we have taken that particular path. So max count should be increased. So we can say max count for our current parent is going to be increased. So it should add a max count of our child parent as well, right? So we can say plus equal to max value count of our child parent and index is 1. Fine. Once we have done this, that means we have taken that particular answer. Now guys, what we can do? We can say guys max value count of our child parent is going to be nothing but guys max value count of our current parent. And why we are doing this? Let me tell you. Once we have taken that particular path, that it's fine. But if it's not the case, then also we have to take that particular value because we can follow that particular path. That means the max value for that particular thing is going to be current parent value. Once we have done guys, so what we can do, we can replace our root of child node with the current parent, right? So we can say now the root of our child parent is nothing but a current parent. Fine. And after that we can return our answer. So we can say return our answer. I hope guys this much is clear to you. Let's try to see whether it's working fine or not, or we are getting any error. So all right, I have to use a double equal to. I can't use a single equal to function. Okay, now let's try to run this code. So here I have to use a vals, not val, right? Now let's run this. Hopefully we should not get any error right now. You guys can see that test cases are accepted. So now let's try to submit this code, whether it can pass all the test cases or not. And here we go guys. I hope this much is clear to you. So if you learn something new in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.